Here is the surface map we're going to be analyzing today, and just for some context, this here is North Dakota, South Dakota, Montana, Wyoming, Nebraska, Iowa, and Minnesota. So this is going to be a northern plains type of setup. Let's start off by drawing in our isobars and just doing a quick scan. It looks like our lowest pressures are kind of right in here. I see a 998, 999.3, 996.9, and that looks like the lowest pressure anywhere. So why don't we start with the 998 millibar isobar? Of course, this is arbitrary. You can start anywhere you'd like. I like to start near the center of circulation if there is one and kind of work out from there. Starting with our 998 isobar, I see a 998 station right here, so our isobar is going to have to go directly through that station. 996.9 and everything around that is pretty much over 1,000 millibars. So why don't we start it right in here? Again, remembering to follow the wind direction. We have a southwesterly wind, so I'm going to go up like that, and then over, given our easterly winds to the north. I see that we have a 999.3, 996.9, so I'm going to keep it kind of right in between those two. And then we have to go up and remember to catch this station in our isobars. So I'm going to go up like that, and I'm going to curve it like that because we have a southerly wind. So our isobar is going to have to follow that wind pretty closely. Then I'm going to go down like so, 996.9, 1,000.2, so maybe a little bit closer to our 996.9 station, and then kind of end it off like that. And of course, remember to label as we go. This is going to be 998. And there is our first isobar. So now let's move on to 1,000. Again, we're going to do it every 2 millibars so we can catch those small scale fluctuations in pressure across our domain. So let's do our 1,000 line here. So I see our 998 isobar, and we have 1,001.1 with an easterly wind. So our isobar might look something like this, a little bit closer to the 1,001 isobar station there. And then we see we have a westerly wind with 1,000.7 millibar pressure. So our isobar is going to look something like this. We're going to have to bring it kind of close there and curve it around to follow that westerly wind. Then we have 1,000.6 and 1,000.2. So our line's going to go down like that and very close to those stations following the wind direction. Then we see 1,001.9. So pretty much right in between those two with a southwesterly wind now. So our isopleth is going to curve up a little bit like so. And then we're going to have to bring it in tight here because we have a 1,001.3 station and our 998 isobar is pretty close to it. So I'm going to have to tightly pack it in, curving it around because of the southeasterly or east-southeasterly wind. 999.3 there, so I'm going to go north of that station and bring it around like so, and then kind of end it off like that. And that is our 1,000 millibar isobar.
The Chaser Academy is the best deal in storm chasing. Click the join button below this video and find out why.
All right, 1,002 isobar here. I see 1,001.1 and 1,003.8, 0.9, 1,006.1, 1,002.5. So let's start it up here. We'll keep it a little bit closer to the 1,001 station. Then we see 1,001.8, so we're going to have to keep it all the way over here and then bring it down like so, following that now northerly wind at that station. 1,003.9, 1,000.7, so I'm going to bring it down like this, and you see we have that westerly wind, so it's going to have to curve back to the right in here. We have 1,002.4 and 1,000.6, so I'm going to keep it kind of close to that station. But look, we have 1,001.7 and 1,002.4, and then everything down here is over 1,002. So this is going to get a little bit tricky. We're going to have to bring it like so, and then kind of right back like this, close to that 1,002.2 station, and then back up so we can satisfy the space between the 1,001.7 and 1,002.8 station. So a little bit of a tricky one there. It'll look something like that. 1,000.2, 1,002.8, so I'm going to bring it kind of like this. And 1,001.9, 1,003.2. We also have 1,001.7 here, so we're going to have to go up close to these stations here and then kind of go like that to capture that we don't have a 1,002 station here. So we can't bring our isobar up in between these two. We have to kind of take it like this and then up around because of the southwesterly winds. 1,001.2 with a southeasterly wind, 1,004.7, 1,004.5. So we're going to take it back up like this, close to the 1,001 station. 1001.3, 1002.5, and then we're going to bring it up like this, split the difference kind of, and then we're going to just kind of close off our isopleth here. And that is our 1002 millibar isobar. So a little bit of a weird one, a little bit wonky out here across Wyoming, but that's because we have that one station there it's below 1,000 millibars with everything around it at 1,002 or higher. All right, 1,004 isobar. So I see 1,002. Here's our 1,002 line, 1,002.5, 1,006.1, 1,006.0, 1,006.7. So our line's going to look something like this. We'll keep it a little bit closer to the 1,002.5 line, like that. Then we see 1,002.5, 1,006.1. So we'll keep it up like that. 1,003.9, 1,006.1. So we're going to take it very close to this station up here and right over like that. And then we'll bring it over here. Hard to read what that station is. I suspect it's 1,005.9 maybe. So we'll bring our isopleth over here. Over here, though, we don't have any more data that we can use to really draw this line accurately, and we have a 1,003.9 station here. So it's likely that this 1,004 isobar goes off our domain here. So we're just going to bring it over toward the edge of the domain. We'll label it right there while we're thinking of it. And then we'll start again down here, 1,003.9, 1,008.1. So our 1,004 line is going to start right there. 1,002.4, 1,008.1. So we'll kind of bring it this way, noting that we have those westerly winds. I'm going to kind of curve it down like so. We have 1,002.2, 1,006.3, so we're going to have to get back down there somehow, and that is how we'll do it. So something like that, curving it back around with the northwesterly wind there. 1,002.8, 1,003.1, 1,007.5, so we'll bring it kind of back over. A little bit of curvature there because of those westerly winds. And then I see 1,003.2, 1,003.8 it looks like, then 1,004. So actually, we're going to have to bring this down a little bit. So let me redraw this just a little bit better for us. Go over like so, and then I will go down and then up like so. And then we're going to have to go back down toward this 1,040 station here. We got to include that exactly in our isopleth. 1,004.2, 1,003.2, so I'll bring it just back above the 1,004.2 station. 1,003.2, 1,004.6, so I'll bring it over kind of close here. Then we see 1,003.9, 1,004.6, 1,005.3, so our line's going to have to go over like this. So I'm going to redraw that just a little bit. So we'll bring it up like so, and then we'll go kind of out like this and just encapsulating that station there. And then back in between this 1,003.9, 1,004.5 like this. So that looks pretty good. 1,004.7, so we'll bring it kind of up here, and then we'll just finish that off, and then we will label it 1,004. We'll label it over here, 1,004, and then we'll maybe do one here for each of these on the bottom portion of the map, 1,004. All right, 1,006 now. So I see a 1,006 station right here, 1,006.7, and our 1,004 isobar. So I'm going to get a little bit closer to that 1,006.7, bring it up to encompass the 1,006 station. Then we have a 1,006.1, so I'm going to bring it just below that station. And then again, we don't have anything out here that we can use to properly and accurately analyze this 1,006 isobar. So I'm just going to kind of bring it right there to the top of the domain. Then we'll kind of go this way with it. So 1,004.7, 1,007.7. So we'll go in between those two stations, kind of like so. 1,004.5, 1,008.6, 1,005.3. So we'll bring it down like this, following the winds. We don't have any pressure readings at this station. We have 1,007 down here, 1,008.4 in our 1,004 line. So we'll kind of bring it down like this. Again, we're just kind of estimating because we don't have any pressure readings at these stations here. So I'll kind of bring it up like that. And then we have a 1,004.6 maybe right there. And then we have 1,006.8. So I'll kind of bring it back down closer to the 1,006.8 station, 1,006.2 as well. So pretty close to the bottom of the map right here. And then we don't have anything else to analyze. So we're just going to have to end it at the end of the domain. 1,004.3, 1,006.2. So I'll start our line kind of like so, and then bringing it up above this 1007.5 station, and then 1006.3 right here, so we'll bring it kind of up like that. Then we have our 1004 and 1008.1, so, it's a little tough to tell, but I'm just going to bring it up like that. It doesn't really matter this far west outside of our area of interest here, and then I'll just kind of end it off like so. So that is our 1006 line. Let me label it for us here. 1006, we'll do one down here as well. 1006. Now for our 1008 millibar isobar. Now, so we'll start up here, and you see we don't have anything to go off of, but we do have our 1006, 1007.8, and then everything over here is higher than 1008. So we're just going to start at some kind of arbitrary point up in here. We'll start it right in there. Then we'll kind of bring it down near the 1007.8, and then we'll bring it down like so. 1006.7, 1009, so we'll bring it a little bit closer to the 1009 station. 1007.7, 1008.3, so we're going to bring it out, splitting the difference between those two. 1008.6, 1010.1, excuse me. So we're going to have to bring it here back inside this 1008.6 station, 1008.1 as well, like so. Then we have 1010.5, so we'll kind of go right in between those two. Again, no pressure at these stations, so we have to go off the ones down here. 1008.4, we'll just go just above that. And then kind of bring it over 1007, so we'll go in between those stations. And then we don't have anything here really to go off of. So actually, look, we have 1007.6, so we're going to have to bring our line. Let me redraw this here for us. 1008.4, then we have 1007.6. So we're going to have to bring it actually down this way, and then we just end it at the end of our domain. So we'll label this one 1008. And I don't have a space down here to label it, but you guys get the idea. That'll be our 1008 isobar. Then let's do our 1010 isobar. So again, we don't have anything to go off of up here. So we're just going to start it somewhere up in here at the edge of the map. 1012.3, 1009.0, 1011. So we'll bring it down like so, and then go right in between these two stations. 1008.3 and 1001, so we'll go like this. These don't have any pressures either, but we have 1014.7, 1013.9. So we'll go down like so. We have 1010 here, so we're going to have to go kind of back this way. 1010.5, so we'll kind of bring it like this. 1010.8 here. 1009.7, so we have to go outside that station and then back inside this 1010.8 station. And then we will just end it at the edge of the map. So there is our 1010 isobar. 1012, starting it up in here, 1012.3, 1011. So we'll go like that. 1015.2, 1014.7. So we'll go pretty tightly packed in there. 1013.9, 1013.4. So we'll go like that, 1010.8, and then these ones don't have any pressure, so we're just going to have to kind of estimate it and then just end it at the edge of the map there and then label it. There's our 1012. And then let's do our 1014. So 1014 again starts somewhere up in here. 1015.2, 1014.7, so we're going to have to go back inside that station there. 1013.9, so we'll go pretty close to that one, and then we see 1013.4, and that is it. So we just end it at the edge of the map. 1014 and then 1016. That looks like our last one. We'll start it up in here. 1015.2, 1016.7, 1016.9, and then we just end it off right there, 1016. And that looks like all we can do. We don't have any pressures up in here. We've kind of analyzed everything out in here. So that is going to be our isobar analysis. Now it's time to place our fronts. First of all, let's place our surface low. And we can see our lowest closed contour is out here in far southeast Montana. So let's place it kind of right in the center of that. That's going to be our surface low center. Let's now try to draw in our fronts, and this is where it gets a little bit trickier than the previous setup we looked at in the last episode. We do have a pretty well-defined pressure tongue across South Dakota into northeast Nebraska, but take a look at the area near the surface low. There's not much of a temperature gradient, although we do see a bit of a wind shift, south-southwesterly winds in far northwest South Dakota, shifting to east-southeasterly across North Dakota and eastern Montana. But there's not much of a pressure tongue or temperature gradient associated with this wind shift. We see a 60-degree temperature there in far northwest South Dakota, shifting to really the mid-50s across far eastern Montana and southwest North Dakota. So not a very strong temperature gradient, and we don't really see a real well-defined pressure tongue there. We just kind of see a cool air mass bumping up against a colder air mass. So not a very big difference in temperature. This is a sign of an occluded front. Now, occluded fronts are pretty tricky to place on surface maps because the temperature contrast does tend to decrease with time as the occlusion occurs. Remember, an occlusion is when the cold front catches up to the warm front and forces all of the warm air off the surface, so you're just left with kind of cool air at the surface and not a very strong temperature gradient. Occluded fronts are also not always associated with pressure tongues, so it does take some practice to actually place occluded fronts on a map. But you're looking for areas where a wind shift occurs with a very subtle temperature gradient at best. So I'm going to start here in the purple color, and I'm going to draw it right through the wind shift, from the surface low right through that wind shift just north of this station in northwest South Dakota, and then kind of bring it down in between where the wind shift is located, and then right kind of through that pressure tongue. We see now as we get down into kind of southwest South Dakota, that we're starting to see a bit of a better temperature gradient. Now we have a 74 temperature there in kind of west central South Dakota, 65 to the north, 66 over here. So once that temperature gradient increases a little bit, that is a potential sign that your warm front is beginning and that you can kind of end the occluded portion of the front. So I'm going to draw it just a little bit farther down in here. And then from there, our warm front kind of takes over. We do see a pretty robust temperature gradient, pressure tongue as well, coincident with that wind shift and pressure gradient. Winds shifting from southerly to kind of southeasterly to the north, so there is a pretty well-defined wind shift, pressure tongue, and temperature gradient here in this area of kind of southern South Dakota within that pressure tongue. So I'm going to start the warm front right there where we start to see a temperature gradient. And I'm just going to draw it through the wind shift here, through southeast South Dakota into northwest Iowa, right through where the wind is shifting. You see that, again, those southerly winds to the south, east, southeasterly, or southeasterly winds to the north, indicative of the warm frontal zone. And that point there, that triple point where the warm front begins and the occluded portion of the front ends, that is where our cold front goes. Now, our cold front's a little bit tricky here. We don't have a real well-defined pressure tongue to help us out. We do see a little bit of a wind shift and temperature gradient, though. Winds out of the west or west-southwest here across western Nebraska, and more south-southwesterly flow farther to the east. And then temperatures in the low 70s out here to the west, temperatures in the mid to upper 70s to the east. So it looks like our cold front kind of stretches through western Nebraska a little bit, even though there's not a well-defined pressure tongue. Again, the wind shift is usually going to be the thing that I rely on most to place a frontal zone. So that cold front's going to start at that point where the occlusion ends and the warm front begins. And I'm just going to drape it right through here, right through where that wind shift is, down into western Nebraska. And then let me fill in our symbols. So the occluded front is those alternating semicircles and triangles. And then, of course, our warm front is those semicircles. The warm air is moving into the colder air from south to north. So our semicircles are going to face toward the north on the cool side of the warm front. And then let's place our triangles on the cold front. Cold air to the west, warm air to the east. So we're going to place our triangles facing off to the east. And those are our fronts. Let's now look for any differential heating boundaries or dry lines in the warm sector. Not really seeing much in the warm sector. We see maybe a little bit of a differential heating boundary, a little bit of a boundary here possibly in Nebraska. We see a moisture gradient, drier air to the west, and a little bit more moist air to the east. So there could be a little bit of some type of differential heating axis right in here. A little bit tough to say if that's actually anything of note. Perhaps a little bit of a wind shift there. Winds just ahead of the cold front out of the south-southwest, shifting to south-southeasterly just off to the east there. So perhaps a little bit of a wind shift, maybe some sort of subtle boundary there. Definitely would be something to watch going through the day of your chase. But overall, our frontal zones have been placed pretty well. So let's check our work. And this is just a computer-assisted version. This is not a hand analysis done by an actual forecaster. The forecaster is just kind of there to check the work of the computer. So this is not going to be perfect, but you can see that we've done a decent job. They have the surface flow analyzed in southeast Montana, with the occlusion perhaps going a little bit farther south than we had drawn it. Again, it can be a little difficult to actually place the surface occluded front because of the lack of a temperature gradient there. I just kind of ended it where there started to be a bit more of a temperature gradient. They have it a little bit farther south, but overall in a decent position relative to ours, with the warm front extending through southeast South Dakota, and then the cold front stretching through western Nebraska like we had it as well. So all in all, a decent analysis for us. Again, this is subjective, so from person to person, there's going to be some slight differences in how you analyze the map. But overall, I think we did a pretty good job with this one. And of course, on top of this, you could add in your isodrosotherms for moisture analysis, isotherms if you need it, and anything that would help you otherwise. But overall, this is what the surface map looks like, at least in my eyes, for this setup.
Remember to check out those links in the description below, and then watch another video.